Saxon's Calculus, lesson 104, is the integral of tangent exponent n of x and the integral of cotangent exponent n of the x. So I have jumped to example 1 on page 510, which it says, find the integration of the tangent squared of x dx. So you need to remember that tangent squared is actually substituted as the equation secant squared minus 1. And then I am integrating, so secant squared goes to tangent, and the minus 1 goes to an x, and then of course every integration has the plus c at the end. Example 2, find the integration of tangent cubed of x dx. So I need to split it to tangent and tangent squared. My tangent and then my same substitution for tangent squared. That distributes tangent with secant squared, and then that makes a minus tangent. I didn't write that out, but that's what that's doing. So when we integrate the tangent secant squared part, we would get secant going to tangent, except it's squared. And then how do I get rid of the 2 that was created? Well, I put the 1/2 in front. And where did that, where did this word come from? Well, it's, when I'm working backwards, the tangent one gives me the secant, but the secant part creates that tangent. Again, it's that integration derivative kind of going back and forth in your head. Then the minus tangent would go to 1 over, and so that's natural log of, and then how do I get the tangent? Well, it comes from the secant, so it's minus natural log of the absolute value of the secant, and then our plus c. Example, sorry, I was double checking one thing on that. Yes, that is correct. Okay, example 3, find the integration of tangent to the 4th. So you're going to split it as you would expect, tangent squared and tangent squared. However, one of them remains kind of like the constant, and the other one gets the substitution. And then just like example 1, when you get down to this end, I'm just going to pull the answer from up here. So when I do tangent squared times secant squared, obviously I have my squared, so when I add the 1, I get the 3, and I have to put the 1/3 in front to remove. So 1/3 tangent cubed, and then of course if you're working backwards, that gives you the secant word coming from that. Then this tangent squared minus 1 is what I had in example 1, so we're just writing r, but it's minusing, so minus tangent plus x, and the plus c from the integration. Then we do the same thing with the cotangents in part B. So example 4 is find the integration of cotangent squared x dx. That is going to change to cosecant squared minus 1 as its substitution. Cosecant goes from cotangent, and because this was the one where if it's sine or its inverse or tangent or its inverse, there's a negative that pulls to the front. That's where this negative is coming from. So when you're doing the cosecant, which is the opposite of sine, or this one either way, you're getting that negative in front of cotangent of x, and then the minus 1 becomes minus x, and obviously our plus c. Example 5 is the integration of cotangent cubed. It's working the same way this one did. So it's going to cotangent, cotangent squared. Here's the cotangent, here's the substitution. Here is just like we did before with the minus natural log absolute value of sine of x, and then of course our plus c. And as you would expect in the final example, they give us integrate of cotangent to the 4th power. So cotangent squared, keep the first one, substitute the second one, and it works exactly the same way as the tangents did. It just has to have its stuff.